Well, hello, everyone, and welcome to another Innovation Coffee live stream brought to you by ARM. My name is Robert Wolf, and I am your host today. And we have quite the lineup for you. With dozens of years of experience and expertise, today's guests will share an hour with us discussing exciting new developments around Px4 Autopilot. We'll talk later about the Px4 open standards, introduce Gumstix FMUv6U implementation, showcase some demos, and a whole bunch more. If you haven't noticed, I'm actually joining you from a new setup. Unfortunately, I'm in the process of moving homes and I don't have my old office. It means I don't have my old mic, I don't have my teleprompter, and I don't have my camera, but we'll make do. So before diving into meeting our guests, of course, we like to do a recap from last week's episode. So last week we met with Blink, that's Blink with a Y, and Arius to talk about these two companies and their low-code, no-code development, the stuff they do around the low-code, no-code space. Blink in particular, who does a lot of this with their platform. So Arius joined us to talk about how they leverage the Blink platform. Now, I don't want to dive into this. We could spend a whole other hour talking about it. If you have an extra hour in your day, cruise on over to that last week's episode. We'll share the link in the chat here. Don't click it just yet. After the episode, check it out. It was a lot of fun. It is on demand now. As for a news update, I want to click where do I do that? Brand. Here we go. Ready? 1, 2, 3. Supposed to have that ready for you. So yeah, as I mentioned last week, Dev Summit, the ARM annual Dev Summit call for papers is live. It went live on May 13th. So last week, go to devsummit.arm.com, submit your call for papers. We love having developers as our speakers there. There are technical sessions, panels, all sorts of keynotes. There's going to be workshops, and we love taking in developers as speakers. So make sure you go submit a call for paper there or submit your paper into the call for papers, and we'll review that. And hopefully, good luck. You get a spot on one of these tech sessions. So very exciting stuff. You have until June 4th. So while you do have some time, don't let it creep up on you. You have until June 4th. As a reminder, if you like these streams, don't forget to hit that like button. Follow ARM software developers on YouTube because we do this every single week, 5 p.m. UTC on Thursdays. Okay, without further ado, we're ready to introduce our guests, and I have their locations here too. I like sharing now. From now on, I'm going to start sharing where everyone's joining us from because this is such a global ecosystem. So joining us from Toronto, Canada, we have Andrew Smith. Welcome to the stream, Andrew. From Cambridge, UK, we have Dominic Plunkett. And from Tijuana, my neighbors to the south, Tijuana, Mexico, we have Ramón Roche. I hope I said the last name right. I don't want to get too on the Spanish side there. But Ramón Roche. So Andrew Smith is an engineering manager at Gumstix Upverter. Dominic is a principal hardware engineer with the Raspberry Pi Trading, and Ramón is a program manager at the Dronecode Foundation. So it's very exciting to have you all here. Welcome to Innovation Coffee. As we usually do, we want to do a quick roundtable so that everyone gets to know who you are. And I think we're going to start off with you, Andrew. Let's kick it off. Who are you? What's your origin story? What do you do? Let's go.
Cool. Thanks, Robert. So my name's Andrew Smith. I've been with Gumstix for 7 years. Gumstix has been part of Altium now for a couple years. I really love building things, robotics. My background's in controls. Really, I just like kind of making things work, making it easy for people to make things work, and just putting things together and doing cool stuff. That's what I love doing.
That's awesome. Actually, I've done quite a few things with Gumstix in the past. Karen Schultz, Keith Lee, people who I hold dear to my heart. One time, several years ago, we got Keith on an old live stream I used to do, open hours. He built a drone. He flew the drone live. It was tethered to the ceiling. It was so cool. Maybe we'll do a clip of that later. But yeah, very happy to have someone from Gumstix here. Thank you, Andrew.
Thank you for having me.
Yeah. Up next, we have Dominic. Dominic, welcome to Innovation Coffee. Could you tell us a little bit about yourself?
Hi, yes. I'm Dominic, and I've been in Cambridge for nearly 25 years now, designing electronic systems for a variety of companies. And 2 years ago now, my friend Gordon, who we were at university together with, and Gordon's at Raspberry Pi, invited me to come along and join the team here. So yeah, I have been at Raspberry Pi Trading designing electronic products, and the main one I've designed is the Raspberry Pi Compute Module 4, and I think we'll talk a little bit about that shortly.
Great. So you said Gordon. Is that Gordon Hollingworth?
That's right. Yes, Gordon Hollingworth. Yes, we were last century now.
Yeah. So for all the viewers out there, you're getting to meet Dominic today. If you go back into the Innovation Coffee playlist, you'll find that we've already interviewed Eben Upton and Gordon Hollingworth. And on the Gordon Hollingworth episode, we talked all about the Pico, and one of their other engineers, Luke Wren, who actually designed the RP2040 chip, or helped design the RP2040 chip, was there. So if you want to go learn all about Raspberry Pi, we've covered it here on Innovation Coffee with the folks from Raspberry Pi. So thank you, Dominic, for joining us. Glad to add another person here to the arsenal of information. Okay, Ramón, you're up. Welcome to Innovation Coffee. Could you please tell us about yourself and Dronecode?
Hi, Robert. Hey, everyone. Thank you for having me. Hola. My name is Ramón Roche. I've been working for the drone industry for the past, I don't know, like 9 years. I started in a company called 3D Robotics back in 2012. I was a tech lead behind their system and tools team. I developed some of their infrastructure and developer kit tools. I kind of had my first feeling for open source in drones. That company, I lasted 4 years. I worked for Chris Anderson, who you might be aware is one of the founders of the DIY movement for open source. He kind of gave me the opportunity to jump into the Dronecode Foundation in 2016. And ever since, I've been the program manager for Dronecode Foundation, trying to evangelize for open source and drone industry. It's not been an easy feat, but we've been so successful. Right now, we had a lot of industry impact. I'm ready to talk to you about Dronecode Foundation, the Px4 Autopilot, and the Pixel standards.
That is exciting. Yeah, Dronecode. I think we had Ginger on to talk.
You had Ginger before. Yeah, that's right.
That was a really fun episode. Gosh, it makes me miss Alessandro as the co-host. Yeah, I mean, we had a good time talking about Dronecode Foundation. We got to see the virtual environment that you all have there to fly the drones and build out your environment. So that was a lot of fun. Okay, cool. So I think we're on to the meat of this episode now. That was a nice quick introduction. I want to get to know the companies here. So we have Dronecode Foundation. Maybe we can start with that. You did touch that this was founded on, do not develop my app. You touched on that this was founded by Chris Anderson, but could you kind of give us a little bit more of a high level view? What is Dronecode Foundation? What do y'all do?
Yeah, for sure. So Dronecode Foundation is part of the Linux Foundation. We actually a collaborative project hosted under the the Linux Foundation. So what we really are is a nonprofit that hosts open source projects and open standards projects for the drone industry. Our main project is the Px4 Autopilot. It's being used in drones out there. Vast majority of drones out there that are running open source are running the Px4 Autopilot. That got started a little bit more than a decade ago out of an ETH lab in Zurich by Dr. Lawrence Mayer, which I don't think you've had at the show yet, so you might need to collect him at some point. He created actually the Pixel standard and the Px4 Autopilot back in 11 years ago in one of his master thesis documents, and then he decided to put everything up in open source. He posted the forum post on DIY drones, used to be one of the main sources of information for DIY developers, and then it sort of kicked off from there. Right now, we estimate we have around 10,000 developers and more than 1 million Pixel devices up in the air. So we've been having a lot of success, and I'm here to talk to you more about it.
That's very cool. Very cool. I mean, when you say drones open source, and it makes me think about, you go to the store, you see all these drones, you can buy the drones, you can, take them. There's not really much building involved. But when you talk about open sourcing drones, that gets me a little bit more interested because there's a lot more to it. So on the list here, of course, I have my list of questions. I want to remind everyone watching, right? You know, we have our questions here that we bring to our guests, but the chat is open. So if you have questions for them, please feel free to post them there. We'll make sure that they get them. You mentioned right now Dronecode Foundation, Pix/Hawk standards, and the Px4 Autopilot. So
yeah, for sure.
Could we dive a little deeper into that? What are the Pix/Hawk standards? What is the Px4 Autopilot? What can people do with this? Where can they find it?
Yeah, so the Pix/Hawk standards and the Px4 Autopilot are two main projects that are driving Dronecode Foundation. So the Px4 Autopilot is actually the firmware that runs inside the flight controllers of the drone. They run everything from control, navigation, estimation. They're the main component of the drone. So the Pix/Hawk standards are the hardware, the open hardware component to all of this, and it was designed to live side by side with the Px4 Autopilot. Right now, we're in version 1.12 about to be released for the Px4 Autopilot. And like you were saying, when you think about drones and open source, it's like going out in the shelf and picking up a drone. It's kind of like that, but not really. We're a layer below. So this drone industry, it's a bit complicated. What we're doing here is we're giving up the layers and the tools for companies to build drones, to assemble their drones. We think ourselves like a 90% solution, and we like companies to pick up our tools and open source projects and standards so that they can focus on the real important parts of their industry. I mean, their verticals like mining and agriculture and defense and security and public safety. So all of those companies that are building drones for all of those services, they're picking up our toolkit because that they're just kickstarting all their development efforts. They're able to prototype faster and get to market faster just by reusing all our effort that have been going for over the last decade. So in summary, it's just the open source software and open core that goes inside the drone.
Cool. So I'm curious, right? You say open source. Usually when you think open source, you think community projects, collaboration. Who's working on this? This is a community effort. We're all building this together. So
yeah, for sure.
Could you share a little bit more about how many people are active? You said 10,000 developers earlier.
Yeah,
sorry.
We're estimating that we have around 10,000 developers. Obviously, like with any open source project, it's really hard to measure exactly how many developers are using like your code or your project. But we've run surveys, we've run various events, and we're estimating right now 10,000. We've run different events right now. We have our flagship Px4 Developer Summit, which I'm going to talk to you about later at the show. But I think I want to touch about one important factor that it's not just about developers. There's a lot of companies involved in this. So right now, the Dronecode Foundation is being financed by yearly memberships by companies that support the open source projects, companies that actually adopt the open source projects and believe in them and implement them. So we have around 40 different members that year after year help us financially to complete our goals. What are our goals? They're really easy to make sure that we nurture the communities around the open source projects and make sure that the projects remain neutral, that there's no one single company monopolizing on any of the projects, and that the project's direction remains aligned with the industry, because it's really important that we're not going in the tangent where the industry is going in this direction and the projects are just going in the opposite direction. So that's part of what the Dronecode Foundation is trying to do and accomplish. We host work groups where the member companies work together to collaborate and develop some of the features that you get to see in Px4 releases, and we develop some tools. So I mentioned a lot of Pix/Hawk and Px4, but there's other tools like MapLink, Map SDK, Ground Control. There are some big components around our ecosystem that are just add-ons on top of what you get by adopting this open source community. So the community is a very tight and very super friendly community. I can't overstate that enough. So I invite anyone to join us.
There you go. Open invitation for the community to join them. So I've heard about this FMUv5X, FMUv6U. These are all part of the Pix/Hawk standards. And I think, Andrew, let's bring someone else in the call. Can we talk a little bit more about these standards and how it applies, or how these apply to the Pix/Hawk standards?
Yeah, absolutely. So the V6U is their progression. That each one you get is getting more advanced sensors. You're having a bigger, a more powerful main processor on there, and essentially it's just pushing it, and you're pushing the limits and bringing in more technology, trying to make things faster, make them run better, and it's just this gradual kind of taking this from something hobbyists are doing and they're flying around their backyard to something it's getting more commercial, and you can do some really legit stuff on this, some cool stuff, and because you've got the hardware there, we're moving that forward. But then the community, the PX4, Tyrian, they're all they're supporting it. We've got this great community of people that are improving the software. They're leveraging and taking advantage of that new hardware.
Yeah, sorry, this is my fault. I probably should have said it at the beginning. These particular devices, these things that I mentioned, they are devices that use the Pixhawk standards. And I believe, correct me if I'm wrong here, the Raspberry Pi plugs into these. It's almost like adding like a shield to the Raspberry Pi, giving it kind of this extra oomph that can be used specifically for drones. Is that correct?
Correct. Yeah, can I share my screen quickly just to show you what the actual Pixhawk devices look like?
Let's do it. Yeah, so these are Pixhawk devices, and we're going to look at which one, the V6U. They all both have that prefix FMU, V6U, and the V5X.
All right, let's see.
There it is, Ramón.
So here we go. So this is the previous family of devices. So we got the Pixhawk 1, the Pixhawk 2, Pixhawk 3, PixRacer, Pixhawk 4, Pixhawk 4 Mini, and then on the very left, the orange one is the first implementation of FMUv6U. That's a flight computer with an IMX on the side. So it's a flight computer with the companion computer. And then about exactly what Andrew was mentioning, how we work together. We're working on the open standards that are part and hosted by the Dronecode Foundation. So one of the things we do is we host work groups where we actually collaborate and create the open standards. So we work together to develop the next generation of open standards. And all of those open standards are made open for all of the members, are accessible. And right now we're working on FMUv6U, which is the industry leading standard. We got FMUv6X, 6U. We got an Autopilot bus and the connector standard. So you mentioned companion computers, and the main idea and the main concept behind the FMUv6X and FMUv6U is that you can have a baseboard. So you got the IMU component, and then I'm going to stop sharing my screen. And then you got a baseboard where you can actually have all the I/O. So on all the I/O, that's where we actually are starting to expose connectors so that you can hook up your companion computer. Traditionally, in our industry, we have been using UART and serial to connect back to the companion computers. But really, I think the future is moving from the flight controller to the companion computer and the power of the companion computers like the Raspberry Pi. So that's what Andrew envisioned with the FMUv6U standard, and what Gumstix is doing with the Gumstix FMUv6U Pixhawk with the CM4. And I think we're going to speak about that next.
Yeah. So I also would like, Andrew, if you could. Thank you, Ramón, by the way.
Yeah, no worries.
I hope everyone liked those pictures there. You can see those. I kind of also want to talk, like Gumstix as a company, I've worked with them. You guys have that Geppetto hardware development tool. Are you using Geppetto to build out these devices, or are you going somewhere else with this?
Absolutely. Yeah. The whole point of this is, well, the standards are there. The Dronecode standards are to push, to standardize these modules, these FMU boards or components, and make it easier for people. And we're trying to do the same thing. So instead of, they're setting up the pinouts, the reference schematics, things like that, and helping companies people and companies getting moving. We're doing the same thing, but the next step we're using, it was Geppetto, it's now called Upverter. We're using Upverter to build all of our boards, and we're using Upverter to make your life easier, democratize the PCB design space, where you don't have to be a double E or have years of experience to design this. You can go in, drag in, this module that's already predefined, and just makes it way easier for you to build this, because all the tough stuff, all the little components are all there already. And what you need to focus on is, okay, hey, I've got this processor that's running here. It runs the FMU, the Px4, whatever software. And now I just need to choose, okay, what companion computer do I want? Let's choose a Raspberry Pi CM4. Okay, let's connect this sensor. Let's connect that. That's what you can spend your time on. So really, that's what we're trying to do with Upverter, is just simplify life, simplify design, and then also take it the next step. And when you go into manufacturing, now you don't, Upverter has it built in, and we're working with partners so that you one click, your board goes to the manufacturer, gets tested, and back to you, and you're ready to go.
Yeah, so sorry about that.
No, it's okay.
Did I date myself by saying
a little? but it's not too old, actually. It's like I think it's 6 months, something like that.
Okay, cool. Yeah. So Upverter, I'm going to share the link here one more time just so we have it all set in everyone's brains there. Upverter.com. You definitely want to check this out. It is kind of like that next step to hardware development, and interestingly enough, super fun when you start getting used to it, because it is this very fun plug and play way to build hardware on your own. Reducing that barrier to entry. So real quick, before we go into this next topic, Andrew, could you just tell us a little bit about this? We want a little bit of a deep dive into this spec, and I don't want to spend too much time on it. And I know Ramon's going to share some pictures here. Maybe while he shares the pictures, you could tell us, what are some of the differentiators from these standards and other standards that are out there?
Well, the main one on this one is when going from the V5 up to V6 is you're now going from an STM32F7 to an H7. So you've increased, you've got more processing capability. I forget exactly all the other little details, but essentially it's just the next generation of processor that's in there. The sensors are, the next one set newer, but really and what we've added in this one as well, with support from the H7, is eventually there will be USB high-speed support. And on the 6Xs, one of the difference between the 6U and 6X is the 6X actually provides Ethernet connection. And then I think Ramón was hinting at it that, right now a lot of the bus communication is done over UART, but you can envision in a not too distant future, there's going to be a lot of this communication that's traditionally over SPI or UART is now going to be over network, over Ethernet. And that's kind of what's moving forward.
Cool.
Let me, he's got the major points. So we've got, these 4th generation or series 4 of the InvenSense IMUs, Bosch barometer, compass, and some of them are similar to what's on previous specs, but the main one is the processor.
Yeah, definitely.
Great. So,
glad I was able to help.
Yeah, so you're up, Ramón. Actually, I think now we're going to talk about the implementation, FMUv6U, right? So you want to take that away? Should we reshare your screen again?
All right, so I'm sharing my screen right now, and it's actually the same slide. So what I want to highlight here is that what Andrew did is he worked together with the Dronecode members and some of the top maintainers of our projects to define a new spec. And we defined the new spec. We came together to define what needed to be in here and what the goals were. So you cannot really appreciate what is inside in here. I might share a link to the slides later with the audience so that they can actually go take a deep dive, or you can go to pixoc.org and look at the actual standards. I just send a link to Rachel. And you'll see all the sensors and all the different parts that are connected. We're sharing the pinout with everyone. But the reality and the coolest thing about this is that the ability to re-implement this and reimagine Pixoc as anything you really want. Like Andrew in this case, he actually thought about adding the Google Edge TPU and adding the CM4, which was a huge innovation into the Pixoc family of flight controllers, because that's something we never had before, and we're really excited to see what the community is going to come up with. So imagine all the capabilities of just having a Google Edge TPU in there, CM4 available at high bandwidth speed. That's just going to open up a whole new level of possibilities. And just remember, this is something that has just come out, and as many people start picking up, they can go to Upverter right now and design their own FMUv6U based boards. So if you go to Upverter, you're gonna get the actual FMUv6U standard, and you were able to put that inside your board and design it however you want. You can change any sensors, you can add whatever you want, you can make it as robust as you need it, or you can make it as lean as possible. So that's one of the main advantages of working with the FMUv6U standard and working with Upverter. That you can actually take out the pinouts, you can take anything you want and make it into whatever really you need, because ultimately, these open standards are very generic things, and they fit the majority of the use cases, but we know that they don't fit 100% of the use cases. So what we're actually hoping here to get is companies that start experimenting.
Yeah, can I jump in? Oh, sorry, Ramon, keep going.
No, I actually wanted to say we should touch a little bit more on the power of the companion computer and focus a little bit more on what the CM4 brings into Pixar, because this is something that is revolutionary.
Yeah, I was actually going to say, Andrew, we can let you chime in just a minute, but Dominic's been waiting so patiently here.
Yeah.
And I think it's finally time here. So you can see, I'm looking at these pictures. There's a Raspberry Pi module on one of these. This is what we're calling the companion computer, right? So yeah, why would someone need to just run this device? Like, I could just take this device, I could throw it on a drone, I can make it. But what's the benefits of having a companion computer? What talk to us a little bit about that.
Yeah, I keep on seeing these pictures of I'm just blown away by what people are doing. But the key there's lots of exciting things with Raspberry Pi compute module. First of all, you can start to prototype your things with just a conventional Raspberry Pi 4, because the compute module is all of the power of the Raspberry Pi 4. There's my camera, in this little compute module here. So it's only 55 millimeters long by 40 millimeters high. And it packs in the processor, the quad-core processor, the memory, wrong side, wrong finger. So that's up to 8 gigs of memory on there, of DDR4 memory, up to 32 gigs of eMMC on board, a wireless module with onboard antenna and optional external antenna as well. Onboard Ethernet, dual HDMI, not suitable for a drone perhaps, but other applications, dual HDMI, dual cameras, dual DSI displays. So there's a huge processing power and interface capability on the CM4. And the base model just starts at 20. That means it's really accessible for people to use and try in products. So that's just a really quick overview of some of the features and power of the Raspberry Pi Compute Module 4. I will just say we have our own development board. One of the other interfaces that is available on the Compute Module is PCI Express. So not necessarily, as we were talking about, interfaces coming along to perhaps using Ethernet now for future standards, but who knows if anybody wants to use something with PCI Express, and that might be an NVMe drive for storing data quickly or something. You have all of that power on a compute module to be able to do that. So hopefully,
yeah, I'm curious now. I would like to explore maybe some of the use cases, right? So what would be some of the things that someone could build additionally, or with this additional compute, this companion computer? What are some of the possibilities that people have? What does that open?
It's endless, and I keep on seeing people do all sorts of things, but there are people who do their own home NASes, their home firewalls, people putting them into all sorts of strange and exotic places, and even drones now. It is all sorts of things. It's wherever you want a lot of computing power you can put it in, and it's easy to do so, especially with using Upverter, which has got all of the, it's got you drag the module, you've got the module. So you don't have to worry about there being BGAs here, fine pitch BGAs, lots of fine pitch components to get right. It is a module. You just clip it in, and you have the computing power. And you will see that we have tried to put as much of the interfacing on here, so you don't need to put hardly any electrical components on your baseboard to be able to use the interfaces. So if you want to use the gigabit Ethernet interface, you just need the Ethernet connector. You want to use the HDMI ports, you just need an HDMI connector. So it's really easy to prototype quite advanced designs very easily.
When I asked that question, I was going to say, sky's the limit. No pun.
Very clever.
Yeah, so we have that going.
It's 4,000 feet is the limit, actually.
Yeah. So very cool. Thank you, Dominic, for sharing that with us. And I mean, it's always amazing to have you folks from Raspberry Pi in here. There's so much cool stuff happening all the time with you. So yeah. I want to move on now back to Upverter, right? And I know that one of the amazing things about Upverter is that you can go in and you can create these templates. And so talking about, these standards that we have, or that you all have with the Dronecode Foundation, talking about these different designs that you all have pushed out with these standards. How can someone else go in? How can someone else go in and take these design files or take these templates and build other stuff? How can they contribute and add to this Dronecode Foundation ecosystem? Did I phrase that question right? I hope I did.
Yeah,
Yeah.
I think that sounds right. Ramón, you want to take that, or you want me to?
Well, I think it would be amazing if we can share our screen and take someone through the whole process of how you would do it, all the way from the Gumstix store. Let me just try to do that right now and see if I can get it right.
And while you're bringing that up, I was going to point out, so this board, particular one we're showing, it's got the CM4 on, it's got the FMUv6. This is not meant to be the be and end all of, this is the newest PIC-SOC, and this is supposed to cover everybody. This was, my use case, what I thought was cool. Like, I love the stuff that we can do with the CM4. Dominic and his team did an amazing job making this that product, and the flexibility and the stuff we can do with it is very cool. The PCIe, by the way, is very handy, having that high-speed bus. And this is kind of what, the stuff that I do, the stuff I'm interested in. This is how I kind of envision. This was my use case. And really what we want this PIC-SOC board at Altium and Gumstix is that we want this to be an example and say, hey, here, I'll try it out. Yep, they did something cool there, did that. But, I really need this port, or I really need this, or I want to put on, like Dominic said, that you've got some NVMe drive. If you want that, you can drag that in. It's really meant to be just an example to kind of get you moving and get you some momentum, being like, no, that's really cool. I know it flies. So now what else can I do with it? What's the next step? And that's what we're trying to do. And so as Ramon's brought up, there's the design template. And so every board that Gumstix, so think of Gumstix now as a user of Upverter. We're kind of we're a advanced user. And as we build every board that we sell, we release the design templates, and people kind of have the choice of, you can take our design templates and you can order it exactly as it is, or you can go and say, no, you know what, I need to do something else. I'm going to rip this off, rip that off. Say you don't need that, you don't need that connector, you don't need CAN, you don't need both those cameras. You can rip them off, but you already know that, hey, those pinouts, those connections, they work. I don't have to worry about it. Or the alternatively, you could start from scratch. So you could start with a brand new design. You could pull in an FMUv6U module, and then you can start making connections. And I guess the third option too, that if you're kind of not board centric, you want to just think about functionality on how can I design, but I don't really care just yet where things are placed. There's a really easy way of doing it called Board Builder, where you can actually go and click and tell it, I want FMU, I want a Bosch, or actually the sensors are already in it. I want a Coral module in there, and you can add those in. So actually, Ramón, instead of you changing, can you just show that quickly? If you go up to the Upverter logo on the top left, you should be able to click and then hit Quick Start Builder. And then so in
There we
here
go.
you can start searching for, okay, the COM processor. I don't think it'll show up in there, but you could. So if you want to put a baseboard around any one of the Raspberry Pis, the CM4, you know, there's jets and stuff in there. You can click on them. They add into your COM processor and sensors. You could put any kind of sensor you want. And I think if you're going down, actually processor, I forget exactly where. I think the FMU shows up under processor, but essentially you tell it which ones you want. There you go. And then you click start build, and it's going to ask you, it's going to tell you, hey, I'm doing this and this and this, and it's going to throw all the stuff on there. I think this actually just added it to your existing one, but you get the idea. And it actually makes the connections for you based on kind of like there's a priority of recommended connections. So it's really easy to get going, and that's it. That's all there is to it. Putting it in there, once it turns green, then hit the order button and it's sent to one of our manufacturers, and in a few weeks you'll get it back and it's fully tested and ready to go, ready to hit the sky or the road, whatever you need.
That's awesome. Yeah, I think people may be watching this if they haven't already tried Upverter, underestimating the simplicity here and how cool and all the cool stuff that you all do on the other side. Once you receive these designs, you take all these components and make it work, and it's pretty cool. Also providing the design files is amazing too. So I want to make sure we have enough time here because I know we have a really cool demo coming up. I'm very excited to see how this happens. I made my sacrifices to the demo gods this morning.
We need it today. Yep.
Okay, Andrew, this is on you. You want to tell us what you're going to be showing us? Because we're about 20 minutes until we close out, so I think we have enough time.
Let me share the screen, the entire window, and then let's see. So can we see? I've got. Oh, let me start up something else.
This is live.
So you've got me. Yeah. Okay. Let me start that. So what? Okay. So I'll set it up. So what I've got is a drone. It's a standard kind of hobby drone that you throw on. I put the CM4 on there. Sorry, the CM4 with the Pixar, the FMUv6U, and what we haven't kind of mentioned too much on it is that it's got the Coral accelerator module. And the really nice thing about this version of the board, and as Dominic mentioned, there's PCIe. We've had some issues being able to connect the Coral directly to the PCIe, but now on this board we've actually got PCIe to USB 3 to the Coral. So now we've gotten this high-speed bus connecting to the Coral, and what the Coral's doing, it's your AI chip. It's doing object detection. It's doing any kind of inferencing. It's kind of doing smart stuff. So that's on there. That's what I'm using the CM4 in this case. Is I've got a camera connected to it, and I'm doing some, as you can see in this bottom picture here, the picture of our house, and it's highlighted a couple people that I don't think are actually people. It's frozen right now. I'm going to start it up in a sec. Hopefully it'll start back up, but I wanted to make sure you can see this. This is the output of it. It's an onboard camera that in real time is running inferencing on what it sees.
Are you?
Yep.
Where are you in that house? Are you behind?
I'm not in the house. If you keep walking back this path, can you see my cursor?
Yeah.
Yeah. Okay. There's a path right here. Walk behind it. I'm kind of in this garage out behind it.
So you're cheating. You're hiding from the drone.
Oh, yeah. Absolutely. I've got. They'll pop into the window in a sec. There's some people waiting behind the camera, and my newly trained pilot, safety pilot, is behind the scenes. She'll make an appearance in a sec.
Cool.
So the other thing we're using the CM4 as well is integrating ROS 2, which I think is a really cool thing. Being a robotics kind of background, just kind of pulling in the drone into the robotics kind of area. So, your standard tools that you're building with, the standard kind of interfaces that you're used to are all available to you. So what I've done here is totally replicated what Nuno Marquez did he's with Arterion, I believe, right, Ramon?
That's correct.
Yeah, and he did a really cool demo that was software in the loop, and I, had some cups of courage, and now I'm hoping that it works in hardware.
Okay, can I give a quick intro
Yep,
to what
absolutely.
you're about to do, just to get a bit more deep
Yep.
dive into the technical details of what's happening here? So, what Andrew has right here is the Px4 Autopilot running on the background. So he run it on the simulation mode, and then he's got running a bridge that is actually connecting Px4 middleware to that is actually UARP. And then we have a bridge that is DDS based. So we're actually talking DDS back to ROS 2. So we're sharing the same middleware. And he's about to show us how by connecting Px4 directly to ROS, he's going to be able to control Px4 from the ROS nodes. So that's what his demo is all about. And he's got it all set up. And I think he's about ready to get started.
Yeah, we're just about ready to go. Thank you, Ramon, for, that's a big part of it. So now you can see the inferencing running, and let's see, we're gonna, so on this middle window, I've got a, it's a ROS, ROS set up there, and I'm gonna, can I move this? There we go. Sorry, I had the thing right where I wanted to see. I'm gonna look at a ROS, the vehicle status. So I can see in real time, you can see those timestamps. It's telling me the state of the vehicle. And I can do all kinds of different things, but that the drone right now is spitting that back. And let me give a shout out to my pilot to tell her that this is going to start up, because I think I can see the remote is still sitting inside there. One sec.
Yep.
It's got a pilot and everything. This is so cool.
Back up. Hey, take off!
Take off.
Yeah, so I have to let them know. I tried to mute. There she goes.
There we go. There she is.
There we go. Yay!
Yeah, here they're gonna.
The support team.
Yeah. Okay.
So we got our crew live.
We're gonna do
and let me. Sorry, I gotta remember exactly what the command is. Here we go. And ROS 2 run ROS. Oh, that was right.
Yeah. So,
Dominic,
you had a question. It looks like maybe we should address that too. Dominic was asking if the link of the drone is Wi-Fi. Ramon, you wanna talk about that?
All right, so I'm not sure exactly what kind of setup he's running with the camera, but the camera is connected directly to a Raspberry Pi. So whatever connection he's got going between the Raspberry Pi and the camera should be high bandwidth enough to get the resolution of the images. But going back to the autopilot, you are actually connected from Raspberry Pi to the Pixhawk via serial, because you don't actually need to send the images back all the way to Pixhawk and to the Px4 autopilot. Well, all you need to do is to send the vectors to control the drone. So that doesn't require a lot of bandwidth, but it does require a low latency bandwidth link. So we're using the UART right now. That's what this demo is connected to. So the CM4 hooked up via UART through the shield on the FMUv6U running on the Px4. So the images running from on OpenCV are, where are you getting those from, Andrew?
It's running through a Python script. This is like off-the-shelf Google Coral examples on image like object detection. Not totally standard, but you can easily kind of think, okay, what can I do with this now? Imagine every one of those, say one of these is tracking, say that bench that's sitting in there right now, say you wanted to track it. Well, this would actually, it's spitting out, some information about it. You could put that into your, that would go either into ROS, or that could be fed directly down into the FMU. You have the option to do something, intelligence with it. You're adding intelligence to the drone by doing this.
One very important thing to mention here is, like, by moving all of the mission control to the CN4, you're actually treating the Pixhawk and the Px4 as a black box of the drone, where you don't actually know what's happening, but it's going to work, and it's going to be reliable. And at the end of the day, if anything goes wrong, you have a log that is actually verifiable, and you can see what happened, because we're actually storing a flight log with a high sensitivity. So we have a lot of high frequency rate logging into that log. So let's see if this demo works. And then if it doesn't, we can actually also go and experiment with the log and see what went wrong.
I want to hear Andrew yell launch again.
No, they're waiting. They're on their toes probably. Okay, let's see how this goes.
Let's do it.
Here we go. Let's see. So you should see the blades spin up. I can't see if they spun up or not in the video. I'll give it a sec.
Make the window bigger.
No, it's set. I've set it at a set frame rate, a set resolution. Let me try it again. I've had to do that a couple times where it has to. Oh, there we go.
It's arming.
I can see it.
Blades are spinning.
I've seen before where it arms and then it goes back off. Let's try this again. So this is going in. Those that are aware of this is offboard mode that I'm using, and it goes into offboard. So it might be missing the. Let's see. Is that going to shut down?
No, it's.
No, come on.
We can do it.
We got this. We got this.
Well, I might have them disarm it and then.
Yep. Can you go back to the PX4 shell?
No, I don't have the PX4. Oh wait, actually no, because the micro RTPS is taking up the shell between the connection between them. Hold on a sec. Let me mute this for a second. I'll yell at them to disarm, and then
while you debug this, let me just give a little bit more explanation to what's going on. So, but the thing is that what PX4 is doing right now is running in the background a separate process, and it's enabling a bridge with the, like I said, the middleware DDS, and that bridge is taking control over the communications back to PX4. So he doesn't have access to the shell, but you typically would have access to a shell, an NSA shell, because PX4 is running on top of an RTOS, is running on top of Apache Nodx, and that gives you the ability to control every part of PX4 as a module, essentially. And we have a lot of tools right there to allow you to arm, disarm, take offs, change modes. There's a concept of modes that we've been discussing, like offboard mode, that we actually didn't talk about. And I'm sorry, because I should have actually brought up those a little bit before. But modes are the way we fly the drone autonomously. So you have mission mode, you got position hold, you got acro mode, you got some modes that are autonomous, you got some modes that are manual, when you got GPS, when you're indoor navigation. And in this case, I think we're going to be using GPS and as well as computer vision. So the reason why you're actually seeing on the lower screen the Python OpenCV running is because that's run completely independently from what's going on in the drone. And as soon as the drone takes over, it's going to start taking messages from the OpenCV pipeline. But it looks like Andrew is struggling to get his drone to take off. So I would suggest hard boot, hard reset, and then try it again.
Yeah, I could go and hit the reset button. I can do it, but I'd have to step off screen for a sec here.
That's fine.
If you're okay with it, just give me 1 second. We'll give that a shot.
Yeah.
Right.
Go handle that real quick. And I mean,
can I share my screen real quick? Maybe I can do a quick demo. Let me see. Let me try it first.
Yeah. So
see if it works.
Be right back to the drone demo. Don't go away. It's gonna go. We're gonna get this launched. Andrew's gonna go reset it real quick. Ramon, yeah, we'll share your screen. Go ahead. Take it away.
All right. So let me just make a quick build to make sure I'm not failing on you as well. But if everything goes right, I'm going to be able to run a simulation environment in a second. So let me see if I can share my screen and share a window.
Yeah, we had a similar situation with Keith's drone long time ago.
Actually, this is not going to work. So I'm building PX4 right now from scratch. So that's why it's taking the long time to build. So this is actually building from scratch PX4, and I'm building the JMap sim. So we have PX4 has a lot of simulator supports. We have JSB sim, we got JMap sim, we got Microsoft Air sim, we got Gazebo, and we got Flight Gear. So we have support for a lot of different simulators. The most lightweight one is JMap sim, which is the one we use the most frequently to actually fly. I think this is going to work. The only problem is that it's going to launch a different screen, and I'm only sharing this screen. So let me actually stop sharing and then share my whole screen so you can actually see the simulator.
How'd it go, Andrew?
We did a reset and we're ready to try again.
Okay.
So you want to do yours, or I can do mine as well? I'm ready.
Yeah, finish yours up there, Ramon, and then we'll go right back to the drone, get that launched, and then we'll just about be out of time, but we have a couple more announcements before we close out. So let's finish up here. Ramon, there you go.
Are you seeing my screen right now? So I was able to build Px4. I got this Java window up here. This is a drone, and I can do ARM, command, let's do help. Then that'll give you all of the different commands. So commander is the main work queue process that actually allows you to control the drone and the different components. So what I did right now is I asked commander to arm my drone, so which means it's preparing the drone to take to be controlled. Pre-flight disarm, commander, arm, takeoff. Then let's see if takeoff detected, and there you go. So takes off, goes to a certain altitude, comes back. So what you're seeing right here is the shell. This shell is the Px4 shell, which I was asking Andrew if he got access to before. And you can get everything in here, so you can inspect the help, and you can inspect everything. So you got a few commands that you can use. And it gives you everything from control to every, you can move from flight mode to flight mode. You can get the position. You can move anything you want from directly from the command line. But most importantly, this was just a very simple demo. I think I want to show off what the possibilities are once you go out and take out of the scope of Px4 and into the realm of the companion computer and ROS. So why don't we go to Andrew's demo?
Bring it back. Our infamous behind-the-scenes producer, Rachel, who no one ever gets to see, but she's the one who's managing all these switches. Thank you, Rachel. All right, there you go. We're back on the drone.
Okay,
so
here we go.
You're up. Arming the drone.
They know they're aware. Let's see. Did it spin up? Not that time. Let me try that again.
So you have, I'm guessing, your wife and kid out there. They're monitoring it just in case something happens, or
yeah, they've got a remote control that they can sit back and monitor. Like if there's anything they need to take control, they can issue they can shut it down.
Gotcha.
Here we go. Let's see.
Spinning up.
Spinning. Good.
Arm the drone.
It still it's still stuck. It's not actually doing the takeoff. I don't think we're going to get anywhere with it, unfortunately.
Why did you think it went wrong?
I don't know. It's
live demos. It's the curse of the live demo.
It's what it should be doing is exactly what Ramon just showed off. It goes up. It basically climbs up to 5 meters, does a slight rotation, and then comes back down and lands. And right now, it just seems like it's stuck in. It's arming, but it doesn't actually want to take off.
Well, at least we got to see the propellers spin. We got to see the virtual demo.
And you can see the live output. So what I'm showing in the middle is actually like, the state, like this, there is this live connection to it that you're getting over the ROS network. We're just not actually, we just can't get that, take off, unfortunately.
Yeah, and it's very cool to see the feed coming in from the Raspberry Pi. So, I mean, I think that the demo, we'll still give this a success stamp.
Yeah.
Thank you.
I want to give a huge shout out to Andrew because he put this together in less than 24 hours and he got a support crew and everything. So that's a huge shout out to him. He got the blade spinning. It's a lot of complexities involved into getting inside the first interaction with the Px4. So it is still a learning curve that you have to go through, and there's a lot of moving pieces. We're improving all of that, and we're working together with Rapón Robotics to make sure that all of our ROS interfaces are solid, and that all of our internal tooling to Px4 actually is really easy to use. I actually just went and did a huge pass through all the documentation because I wasn't really happy with the state of where we were, and now we are in a much better state. I wish the demo would work. I think it was much of a fail-safe or something. We're probably missing something really small that we're gonna figure out as soon as this meeting ends.
Yeah.
But huge success. Thank you, Andrew. Thank you for coming. Thank you for the demo. It was amazing.
You know what we can do also? I mean, if you want next week or the week after, we can reserve a little 5 or 10 minute section at the end of one of the innovation coffees. Speak with Rachel, and we'll get you back on here, and maybe we can just do a quick launch just to
absolutely.
So we'll get that all figured out. So I know we have one last thing to cover here, and that is an event that you would like to talk about, right, Ramón? Because I think that's important.
Yeah, and thank you. I know we're really out of time, but I want to invite everyone to the PX4 Developer Summit. It's a yearly flagship event. This is where all of our community meets. The registration just opened on May 10th. We have an early bird discount right now for $10 tickets. That's a huge discount. It's a 90% discount. We're selling tickets at $100. And right now until May 4th, thanks to all of our sponsors, we're giving away $10 tickets. The call for proposals is also open. That is going to close soon on Friday, July 23rd. So you still have a lot of time to apply. I invite everyone to go and look at the event website, which it's thank you, Rachel. It's linked right there. You can also go to our YouTube channel, which I will link real quick on here so that Rachel has the link. And if you're unsure what to expect about these events, I would tell you to go to our YouTube channel where we have all the sessions from our previous events. And you can see all of the technical in-depth that we go. Last year, we had more than 1,600 registrants. We had an average of 900 viewers. We got more than 56 speakers from all around the world. We have a huge community, and we're really happy to be able to host this event again. You're all invited, and it's going to be a tremendous party. It's just going to geek out on drones and just all around be happy and discuss everything that's involved with the 8.0 ecosystem. Robert, I'm hoping you're going to be there.
I'd love to be there. Yeah. Is this in-person event or is this virtual?
No, we're going to do it virtual this year.
Yeah. Okay, cool. I can be there then. Yeah. I love how as engineers, as developers, this community, we can say we're going to build drones, geek out, and still use it in the same sentence as party.
Yeah.
So that's pretty cool.
And there's actually going to be a big after party online. So
nice.
Stay tuned for that.
Very nice, very nice. So, before I close out the episode, Ramón, thank you so much for sharing that. I want to give Dominic and Andrew, each of you, just a quick opportunity. You have a shameless plug, something you'd like to say before I close this out. We'll go with you first, Dominic. You're muted. There you go.
Shameless plug. All I would say is go and have a read of the documentation of the CM4. There's a lot of useful things in there.
Excellent. Cool. Yeah, thank you. Andrew?
Upverter. Check out Upverter. We've still got a promotion on right now for the CM4. So design something with a CM4 in it, and there's no manufacturing fee. You're basically just paying what the cost of the board is. And we just added, and it's just been kind of approved or pushed by Google as well. Now Upverter is the first place to be able to easily design in USB 3 connection to the Coral accelerator. So it's in there. It's ready to go.
Very, very awesome. All right.
Andrew, you're also a partner of Google Coral, right?
Correct. Yeah.
Cool. All right. So, gentlemen, thank you so much for your time today. I know it's valuable. You spent a whole hour with us, and all the people who are watching, thank you very much for spending your hour with us. It means a whole bunch. I want to just comb through this real quickly. We met with folks from Dronecode Foundation. Go check out dronecode.org. Gumstix.com. Here you can go find the CM4 Px4 UV6 model there, so you can go check that out. If you want to comb through the entire website, Gumstix.com. Go check out Upverter. Build your own hardware. Lots of really fun stuff. This is where you get the templates for all the things we were talking about today. Don't worry, this will all be inside the description. RaspberryPi.org, of course, one of my go-to websites. I think I check it almost at least once a week. Check stuff out. pixhawk.org. Lots of cool stuff going on around there. Definitely touched bases on that. And then last but not least, events.linuxfoundation.org if you want to go attend the PX4 Developer Summit. So everyone, thank you very much again for your time. I'm going to wave you off here. Let's get that outro screen going. Bye.
Thanks, guys.
Bye. Thank you, everyone.
Take care.